Okay, now I'm recording.
We're good?
Yeah.
We're good?
Mm-hmm.
Okay. So going back over the periodic table, your alkali metals, your alkaline earth metals, transition metals. Over here you have your boron, silicon, germanium, arsenic, tellurium, and antimony, which are your, what are they? Metalloids. And then you have your halogens, which are here, fluorine, chlorine, bromine, iodine, so forth. And then your noble gases, neon, argon, and so forth there. We know that the diatomics are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, meaning they have the I2, the Br2. And then we know we call them our weirdos, which are just not diatomics, but they're exceptions, which is P and S, P4, S8. And basically what that means is they do not pair. They're okay with their pairs, like hydrogen and chlorine would be okay together to make hydrogen and chloride. It'd be okay to do that. But if not, hydrogen's going to have H2 and chlorine's going to have Cl2. Okay? That covers the metalloids, it covers our diatomics and so forth. Let's talk about house rules, and that's going to be our group 1 and group 2. And then there's 3 or 4 other little guys, the transition metals that we know they charge all the time, they don't change. We count over 1, 2, and 3. We know it starts with a 3 charge. Al is positive 3. Zinc and cadmium are our positive 2s, and Ag, silver, is our positive 1. Okay? On the back, actually, let's go back and finish this last little bit. On the front of it, right below your atomic numbers and atomic masses, look, there's a little number in the corner. It's called your electronegativity. We talked about this, meaning that if we go from your right, we go from here, we get bigger with our radius, and we get really big with our radius as we go down, atomic radius, and everything's opposite with electronegativity and ionization energy and electronegativity. For example, as you go up, you get bigger, and as you go this way, you get bigger. And if you notice it and you can remember it, you'll see it says right here, for example, 0.81, 1.3, 1.5, 1.6, 1.8, 2.0, and it shows you that pattern on the periodic table. On the back of it, you will see that your polyatomic ions are there. There is your positive charged atoms, your negatively charged atoms are there as well, and they're all labeled. And so then you even have some of our transition metals and the possible charges that they are. So that'll help you whenever you're naming your covalent and your ion bonds on the test. Okay? Are there any questions about your tool you're going to use? No. So a little rundown on significant figures. We're going to go over that fast. You may have to adjust the video just this way so you can see the board. I don't know.
I got you. It's good.
All right. I'm going to let it go, and then when I get through the significant figures, I'll let you stop it, and then we'll pick back up, okay? So in our Unit 1, we basically touched all of the measurements and how to address our units like significant figures of precision and accuracy. We know that precision and accuracy is whenever you get something right on the money every time, right? And precision is actually getting the
closeness.
Very good, very good. So precision is not the closeness to what it's supposed to be. So whenever we're looking at our actual data and our theoretical data, if we get really, really close to our theoretical data, then you're precise, right? Okay, if you get over here, and here's your data, your theoretic here and your actuals over here, and every time you get it, you are actually being very accurate, but you're not precise, okay? We talked about the scientific method, and that's what you've been discussing in biology, physical science for a couple of years. We discussed about what a law and a theory is. Basically, the laws, the hypothesis proven true over and over and again. And then a theory is just kind of like in a big thought that has a bunch of facts intertwined, and those facts can be proven, incorrect later on in life. Think about the atomic theory. He had all these postulates or ideas, the 5, and then all of a sudden, 2 of them are all incorrect. As far as measurements go and discussing with significant figures, we should touch base with some rules. And so there's the rounding rules that we discussed. There are the 0 rules, and you can't see that green on here. The rounding rules, the 0 rules, the multiplying and dividing rules, and the adding and subtracting rules. So adding and subtracting, basically will be the same. You'll line up your decimal places, 34.25, 25.48. And what do you do? Remember?
For adding?
What if it were 6? We add it all together. 6, 13, 7, 9, 5. We get this answer. How do we round it?
We leave it.
We're not leave like that.
How many significant figures are in the largest or the smallest?
So it's the smallest. So there's only 2 degrees here, and you're looking at the decimal number. So there's only 2 degrees here, right? How many degrees here would you want? So we'd mark off this little guy. And we would actually round it. And if that were a 6, we'll come back to it and we'll discuss how to round it in a second. So we look at the 3, that's where we're going to round to. Look at the 6, and it is above the 5. So we can successfully change this to a 74. Okay? If we're multiplying and dividing, very similar rules. Basically, 3.04 times 2.1. So we got 304, 608, 63, 84, 123.
I would just like to say congratulations to Cammie Cross